Okay, hey, real quick, 603. This is due today. Okay, 603, due today. This is the last assignment on this quarter. This is the cutoff date for it. I want this assignment in preferably today, unless you've been gone. I know, like, whoops, you've been gone the last couple days. This is due. I'm going to try to get this graded today and hand it back to you tomorrow if you need to make fixes on it. Today, I'm also going to be handing back some old papers to you. If you want to make fixes, turn them in by this Friday. Any late work, by Friday. I know your grade book, as of this moment, is completely up to date. Everything's in. The only thing that isn't are these that you just turned in a little bit ago, and or assignment, a late assignment that somebody turned in earlier to me. Okay? So, everything else is in the grade book. So you can see if you have an MI or an LI, you need to get those turned in. Okay, got it? Okay, you need to have your property sheet out. The one with the big unit circle. Have it out right now. Go. Tori, I have a form for you for basketball. It's a letter. So, I keep forgetting. Coach reminded me like 7 times this week. You need that. There you go. Congrats. All right. Okay, today. Hey, today I'm not going to deal with people talking today. I'm not in the mood today. Unit circle. You need to have it today. We're going to use it quite a bit. Second thing today. The property sheet. We have a lot of stuff to cover on it and some stuff we have to correct. There are some incorrect names on this property sheet. I've been looking through it, trying to figure out what we have. This is the new stuff we started yesterday. You need to put a box around it. Now where this is found, on the side where it says cheat sheet, if you go to the bottom, it's in that middle column near the bottom. We did double angle formulas yesterday. It was these select, 3 that we did.
Mr. Ward, is it really a cheat sheet if you give it to us?
Yeah.
Yeah.
All right.
I'm looking for mine.
Okay. Just wait.
Sorry. Bye.
All right. So. All right. Hey, double angle formula. These 3 are the main ones we had. All right. Hey, you guys got to separate now. I'm not dealing with it today. I'm not in any mood. 3 of you moved 2 different spots around the room. I'm not moving. I'm not dealing with this today. I'm in no mood. We have too much stuff to cover. And I only have about 30 minutes to do it. Okay, double angle formulas today. We have 2 new ones we have to cover because we have to cover cosine. If you're looking at the cosine one here on your property sheet, there's some mystery ones here we have to talk about. There's 2 extras. I said cosine has 3 of them, not just 1. We have to talk about why there's 2 others and what do we need them for. Other than that today, we are going to get to other properties. We have half angles and power reducing today. I'll show you examples of how to work them today. They are not easy. You need to see them so you know how to use them in calc or pre-calc or later on. Okay? All right. Let's get to our new stuff today. But does everyone have a box around their double angle formulas? Okay. Let me get rid of the property sheet here. Let's talk about those 2 mystery ones today. So, goal today. We're on section 5.3, which is the final few formulas that we have. Here we go. So 5.3 talks about double angles. I want to talk about those today. Namely, we need to get to those mystery ones, which are about cosine of 2 theta. So we're going to do the double angle formulas for cosine. Okay, are we good with that first one?
Yes.
Okay, second one we're going to talk about. We're going to do the power reducing. These are the ones that are incorrectly labeled on your property sheet. We'll have to fix that. And then so we will make fixes on that property sheet. So on the cheat sheet. And the last ones we're going to talk about today is half angles. And that we're going to do an example of half angles today. Hopefully this will make sense why we have those. Those are based on the power reducing, which are based on the double angle. So we have to get to the double angles before we get to the last part. We have a lot of stuff to cover. We have, I think, 2 or 3 different examples I'd like to do today. 2 for sure. And this is going to take a while. We have a lot of things we have to write down. There's some things we are going to add to your property sheet. Things that are not on there, you definitely need. The reason why, the cheat sheet had things that were incorrectly labeled. And so we're going to have to add some new stuff. Okay, and we'll have to get to the half angles. Now we're not going to finish half angles today, we'll probably finish tomorrow. The goal today is just to introduce the first 2. Alright, here we go. Cosine, double angle. This is the formula we had yesterday. If you don't remember it, it was cosine squared of an angle minus sine squared of an angle. That was the formula we had written down yesterday. We did an example of it where I think I used like 120 degrees or something like that. We did an example of it. Now, goal today is to talk about how do we get to those other 2 mystery formulas. Here's how they do it. They take one of these and substitute it out. What I mean by substituting it out, it's using a Pythagorean identity. So let me write down the Pythagorean identities here. These are the ones you have there on your cheat sheet. The Pythagorean identities, there's 3 of them, but I always use that top one probably the most. It's the one where it says sine squared plus cosine squared equals 1. That's the one of the properties in your property sheet. Well, what I'm going to do is I'm going to pick one of these and I'm going to substitute it out and simplify. So let's pick one of these right now. Sine. Sorry, I heard sine first. Okay, so we're going to take out the sine. And what we're going to do is we're going to plug in something of equal value. And you're absolutely right. We're going to be plugging in a version of cosine. So how this works, what I'm going to substitute out is just sine squared here. It's just in the bubble, it's missing. How I'm going to do it is I'm going to do a form of this. Sine squared is equal to, if I move this to the other side, sine squared is equal to 1 minus cosine squared theta. That's a rearrangement of the Pythagorean identity. I'm going to take this mess right here and substitute it in. The reason why is 1 minus cosine squared is sine squared. So that's of equal value if I plug this into this spot right here. Because that's what sine squared was. It was 1 minus cosine squared. And now I'm going to distribute the negative sign into this parenthesis. I'm going to substitute that number in. And this is what I have. I have cosine squared theta minus 1 plus cosine squared, because when you actually distribute the negative sign, it becomes negative positive, and these 2 can add together. So this is what one of those formulas are on your property sheet. It says this. It says 2 cosine squared theta minus 1. Now the reason why I get that, this is one that's on your property sheet. You can see it. It's because I added these 2 things together. Cosine plus cosine makes 2 cosines. Questions on that one that's the mystery one that was on your property sheet? Now, there is a purpose for me writing these down today. The whole reason for why I wanted to get to that one, we needed that one to go further, which I know is kind of goofy. Okay. Alright. Are we good with 2 cosine squared minus 1? Okay, let's do the other one now. So I'm going to do the other side. So probably just filling in here. This formula is the one we talked about yesterday. The problem is, if you look at your property sheet, there's 2 mystery ones that are attached to it. Like they have a different formula on your property sheet because they rearranged it and solved it. So that's what we're talking about. We're talking about how do they get to those other 2. All right, but let's do the other one. Now, same exact formula, but now instead of this one, now I'm going to substitute out cosine instead. So it's the exact same formula I just did earlier, but now I'm taking out cosine instead. So if I take out cosine, the actual material that I plug in this parenthesis is a version of this where if I rearrange this, it'll be cosine squared equals 1 minus sine squared. So that's your Pythagorean identity. This is the part I'm going to substitute onto this new part over here. I'm going 1 minus sine squared. And if I actually if I get rid of the parentheses, because I don't actually need it, I'm not distributing anything into the parentheses, I have 1 minus sine squared minus sine squared, which if they're both negative, that makes negative 2 sine squares. This is the other formula, the mystery one that's on your property sheet that a lot of people always wonder, like, why is there 3 of them? These 2 that I have in the boxes are the most important formulas we have today. I'm not joking. Without these 2, we would not be able to get power reducing or to get to those half angle formulas, which we're about to do here in a little bit. These 2 are insanely important. So the goal is to show like what the power reducing are and how do we use these 2 to get to it. But you need to have these written down. In fact, I'm going to put them off to the side here in a second. But if you have not already, I would like you to write down this original one, this is the one we had yesterday, and then you need to write these 2 next to it, somewhere like maybe below it.
Wait, on the cheat sheet?
They're on the cheat sheet. But like in your notes, if you're writing down notes for this stuff.
Okay.
They're on the cheat sheet though. It is important that they're on there. Okay, are we good so far? Okay, so those are the 2 in the boxes are insanely important. I'm going to show you how they get to those new formulas and what we have to make fixes. Because if you're looking at the board here, we do have to fix one of the properties that's on your cheat sheet because it's incorrectly labeled. And so we'll have to talk about it.
Wait, so these 2 in the boxes are from that one?
They're from that one that we did yesterday. They're just a different version of it. But they're insanely important. So, I'm going to put these off to the side just so you can see this. Alright. As you guys are writing that down, because I know some of you are trying to put that in notes somewhere. Okay, here we go. Cosine 2 theta is equal to cosine squared minus sine squared. Or 2 cosine squared minus 1, or 1 minus 2 sine squared theta. Okay, so those are the 3 you should have written down because those are the ones that are in the boxes. I just transferred them over there so you can see all 3 back to back to back. Got it? Okay, they are on the property sheet though. So all I did was transfer those things over there so you can see them all next to each other. But again, they are on the property sheet. You don't need to add them to it. But we're going to show how we're going to use these here in a second. Now, the reason you're probably wondering, Ward, why do we just move those over? We need to go back to our property sheet and talk about something we need to fix. Can I erase this stuff right here?
Yeah.
Yeah.
No?
Go for it.
That's fine.
Okay, never mind. Erase it.
No, you're fine. I'll do it for a few seconds if you need it.
We have 49 days of school left.
Good. Okay, we're good though?
Yeah, we're good.
Alright, I'm going to get rid of this. Now, you need to have that property sheet back out because we're going to make some fixes. And it's nothing too major. It's just they have something incorrectly labeled, and I understand why they did it, but I don't like it because it is wrong. It is written incorrectly. So here we go. Okay, here's your property sheet. Okay, I'm on the side where it says cheat sheet. I need you to go up in this upper corner up here and zoom in right here. Okay, so we're zooming in right here. Okay, so this is the corner that I'm in, the upper right corner. Okay, I think we already had a box, if I'm not mistaken. We had a box going down the middle.
Yep.
We had a box over here.
Yep.
But this one right here is incorrectly labeled. You need to scribble these words out. They say half angle, that is incorrect. I understand why they write half angle, but that is not the correct half angle formula. What they're showing you here is something that leads to the half angle, but it's not. In fact, this label that you should put here is actually called the power reducing formula. These are the power reducing formulae. So they're incorrectly labeled. Now, this is one I want to show you how do they get to it. Why is that a power reducing? What can we use it for? So I'm going to do a very kind of challenging example today. Okay, are we good?
Yeah.
All right, let's get to this part. So everyone has that fixed though on their property sheet.
Yeah.
Okay, let me get rid of this. Let's talk about the power reducing. All right. It's based on this one right here. Cosine 2 theta equals 2 cosine squared minus 1. This is what it's based on. Okay, how they actually get power reducing. It's any time on a trig problem that you're working on where there's a bunch of squares everywhere. You're allowed to substitute out things that have powers of 2's on it, like squares, and plug in things that do not have powers of 2's. So it actually makes the problem a little bit easier in terms of calculation. You wouldn't need a calculator in certain cases. Right? But the actual process of doing this is not easy. So how they actually do it, they actually just solve for this. What I mean by solve, it means to rearrange. So if you're going to rearrange the original problem that I have there in blue and have cosine squared by itself, that's the power reducing formula that we had correctly labeled on our property sheet. So what I mean by this, if I want to get this cosine squared by itself, what do I have to move first? Not 2. The 1. You have to move the 1 over first. When I move the 1 to the other side, you have to add it. You add the 1 to the other side. Now, how do I get rid of the power 2, or how do I get rid of that 2 now?
Divide.
Divide. Divide by 2. Divide by 2. 2's cancel. Let me move on.
Now we got 1 plus cos squared theta equals.
This part right here, what you're looking at, is the power reducing formula that we have correctly labeled on our property sheet. Okay, now,
That's a
okay, what is this? Like, how do we use it? What is the whole purpose of doing something like this? Here's the example I want to show you how we use power reducing to actually help us simplify problems. Even though it may not look simplified, it will definitely help you in the long run without having powers in it. Because if I were to try to solve for theta, in this case, I'd have to do square roots, and those are things that a lot of people can't take square roots in their head. They can't do calculations of square roots. You need a calculator, and you'd have to go from there. If we get rid of powers, you won't have to worry about square roots, so it actually makes the problem easier to work on. Okay, so here's what I mean. Let me give you an example. This is a problem that I saw in your book. This is a problem that I saw in your textbook, and what it said is it said reduce this trig function and get rid of any power. So you're reducing all powers to degree of 1. So we're going to try to show you how to do this. This is not easy. All right, we got to go with the setup. Sure. Because I have a lot of people talking here. Okay, first step. This part right here. This is cosine squared theta, but squared again. That's what it stands for. Now, why I'm doing that? I'm going to get rid of this cosine squared, and I'm going to substitute this mess into it, because this mess doesn't have a power, doesn't have a degree of 2. So I'm going to plug this into my actual problem. So it's going to be 5, 1 plus cosine 2 theta all over 2. And this whole thing is squared. Now, you're thinking, okay, that still has a power, it has a square. The whole point of this problem is to get rid of the powers. So there's no powers of 2's. Anything on this problem can only be degree 1. So, what I have so far is I have this problem where it's squaring a fraction. So I have to square top and bottom. That means I have to FOIL it out, because there's actually 2 parentheses here.
4 is on the bottom, I guess.
Yep. So if I actually multiply this out, so I'm going to actually FOIL that whole mess out, first, outer, inner, last. And then, once I have that, there will be another square, and I'll have to substitute that out again. So here we go. And again, the whole point of doing this is so you can actually find a calculation for theta without using a calculator. The squares, most people have to do it with a calculator, especially when you're trying to take a square root. But anyways, multiplying this together, foiling the top, I have 1 plus 2 cosine 2 theta plus cosine squared 2 theta. All over, if I multiply the bottoms together, I get 4, and this is all times the number 5. Agreed with how I foiled the top, bottom together
Sure.
when I multiplied straight across?
I trust you.
2 times 2. When you multiply the top, you have to go first, outer, inner, last, so I get this. I'm gonna separate the 4 to each item, and I'm gonna distribute the 5 through the parentheses. So when I do this, here's what I get. I get 5 over 4, because that's 5 times 1 and the 4 goes on the bottom of it, plus 5 times the 2 with the 4 on the bottom. So that'll be 5 over 2 cosine 2 theta. Now if you wish, you could write it like this. Some people like to write it where there's a fraction out front. This means the same thing. If you were to actually multiply the cosine 2 theta on this fraction, it goes to the top. And again, I took 5 times 2 divided by 4. And in the back, I have 5 over 4 cosine squared 2 theta. Now the last part here is get rid of the square still. Does that problem still have a square in it?
Sure.
We have to get rid of it. We have to get rid of it one more time. So you have to substitute it out again.
Oh my god.
So if I substitute this out, I'm plugging the thing I just used a little bit ago. This is the item I'm plugging in to this square. The only difference here, since I'm taking out the cosine squared, this one has an extra 2 in it. It's cosine squared with a 2 theta. So the only difference here is I have to have an extra 2 in there with the theta.
So it's 4.
So it's 4. So here's the idea. So I'm going to take this out. So this will be 1 plus cosine 4 theta, because I have an extra 2 in there, over 2.
Is that adding or multiplying?
Multiplying. It's 2 times the 2 theta that's already sitting there. The 5/4 is sitting outside of it. The 5 halves, cosine 2 theta, and the 5/4. And again, now a lot of people always wonder, like, Ward, why are we doing this? I understand, like, you're getting rid of powers, but why? Because if you're doing a problem where you had to solve for theta, and you had to do it without a calculator, like, because that's what they have in college. You're not allowed to use any graphical calculator, any electronic device to find answers. This is actually how you're supposed to do it without a calculator, because typically these answers will be provided to you in an answer bank on the test somewhere without powers, because we can't take square roots and stuff. So they try to give you certain things you're allowed to use on the test. So in our case, they might have a cosine 4 theta somewhere in the answer key. They might have a cosine 2 theta, and they'll ask you to multiply all those numbers up by hand. I had to do that quite a few times in a Calc 1 course and Calc 2 course.
Quite a few? Like,
Quite a few times.
Like at least 4 or 5?
For the test, yes.
Wow.
There's almost every test you're not allowed to use a calculator, because kids would just type everything in the calculator and just store it.
Yeah, that'd make it a little easier,
So
wouldn't it?
they don't allow any calculators to use.
So what do they do if you have a calculator?
You're not even allowed. If they see it, you're done with the test.
And then you get a 0?
Yep.
Why don't they just provide calculators?
No, they're not enough. When you have a lecture hall of 300 kids, they don't.
Did you ever have a class of 300 kids?
Almost every single calc course I have.
Oh, that's good.
So there are a lot of questions.
What was the smartest one?
Wait, do a lot of people ask questions in a lecture like that?
What was the smallest class you ever had?
20, 30?
Wait, is it like the odd every day?
Yeah, it was like an auto.
That'd be a terrible place to live.
It was nice. You just kind of relax.
They have big screens.
Yeah.
You,
All right.
they would not, you would not be, the professor would not be able to tell if you had a calculator.
When you're testing, trust me, they watch you like hawks. Plus they have TAs in the room.
Mr. Ward, did you ever cheat?
So,
Ever?
no.
In high school?
No.
Middle school?
No.
Elementary school?
All right.
Preschool?
Hey, questions on power reducing? Okay. This is an example of how to use it. Now I'm going to go through the next one, and then we're going to show the half angle formula. So, does everyone have this written down though? That's your one example that looks really close to a homework problem you're about to get in the next 2 days.
Hey, wait, can I take a picture of it?
How about you just write it down?
Well,
Okay.
I
Pictures
know
are
that's
better.
really behind, it's gonna take me
Well,
long.
just write it down.
It's color coded though.
We'll wait, don't worry.
What if we don't color
Please
code?
wait.
We will wait. We can wait all day actually.
Teachers aren't allowed.
I mean,
Like teachers can't?
I bet you they could if they wanted.
No.
Why can't teachers?
If you have enough power as an individual to walk out those front doors at 10 a.m. tomorrow.
Wait, why are teachers not supposed to?
It's part of our job. It's not a civil rights
Yeah, I think
issue.
it's stupid if people do that.
Oh wait, so you're not like supposed to
I don't
show
wanna talk
your
about this whole
side?
thing right
Let's
now.
talk-
Not gonna happen. Nope.
Okay.
I'm not gonna talk about it. Okay. Questions, comments about this problem?
Not yet.
Would you ever go on strike for a pay raise? Yeah. You should do it. You should start up a movement in the GHB.
We should do that then.
Is the camera still on?
Yes.
I-
Don't worry.
I
Don't worry.
Website.
Don't worry, I'll cut that
I
out.
wish like
No,
people,
don't.
I wish people like
I always do.
watch the videos like a lot.
You
and
cut out
just
stuff
realize.
No, we have some deep.
How many views do you have? What's your the most views on one video?
I saw one that had like 35.
14 maybe. I'm a small fry.
No, I saw one that had like 30, but it was from like 3 years ago.
Hey, okay, here we go. We're good?
Phoebe, how
All
many
right,
years
we're
have you
moving on.
Is that it for today?
Okay, hey, next thing. The second power reducing formula is sine squared. So this is what you have to have somewhere on your paper. Okay, sine 2 theta, 1 minus 2 sine squared theta. All right, we're going to talk about the power reducing formula for sine, because again, this is on that property sheet, but it was incorrectly labeled. How they solved it, they solved for sine squared by itself. Okay, all right, so again, this is your power reducing formula for cosine. This is the power reducing one for cosine and sine, so I showed you both of them. We talked about tangent, how to do the power reducing formula for tangent. Now we got to talk about the half angle formula. And I'm going to show you how they came up with it. We're going to just do it for sine, and we'll do an example of it, because this is going to be the easiest one. In fact, I'm going to leave this on the board.
You leaving the tangent one on the board or?
Sine.
The theta. The theta.
The fish one.
Yep.
The theta.
Okay, here we go.
The theta.
All right, to get to the half angle formula, it uses this one. So what I want to show you here is how they get to it. I'm going to rearrange this just so you can see this. So here's your power reducing formula for sine. I'm just rearranging this problem. All
You're
right,
also solving the problem. Rearrange. equals-
rearrange. Yeah, it's not really solving yet.
Transitive.
Okay, all right. Here's how it works. To get to the half angle formulas, here's what you do. First step, you take the square root to the other side. Sine of theta, and if I take the square root to the other side, it's plus or minus. Okay, so that's the first step. You have to take the square root because I want to get sine by itself. And then the last step is I'm going to replace all the thetas, but I'm going to replace them with
Alpha.
alpha over 2. Now, why I'm doing alpha over 2? This is a half an angle. It's taking alpha and dividing it by 2. So whatever theta was, I could figure out a number that they cut in half that made theta. So let's say theta was 22.5. This angle would be 45 divided by 2. Because 45 divided by 2 is 22.5. So you can get some weird decimal numbers and we can still solve it. Now the thing is, once I replace this with alpha over 2, you have to go in the formula over here and replace any of the thetas with alpha over 2's. And when you do that, it simplifies because what happens with the 2's here?
They cancel.
They cancel. So here's what you're left with. Sine of alpha over 2. So a half angle formula is plus or minus square root 1 minus cosine of alpha all over 2. Because this, what you have right here, you need to add it to the bottom of your property sheet. The bottom of your property sheet, and you need to relabel these as the new half angle formulas.
Half angle.
Half angles, this is one of them. We're going to do cosine tomorrow. And we'll do the formulas for tangent tomorrow. Tangent actually has 3 of them.
Where should we put this?
On the bottom of that property sheet, it has to be in that white blank at the very bottom. You can put them off to the side. So if I was doing this, can I borrow one of your sheets?
Absolutely.
If I was doing this, I'd either do it like on the sides, like what some of you are doing, or the very bottom and just label them half angles. And we're doing sine for right now.
Thank you, Mr. Ward.
Oh my gosh.
That was very important.
Just the record.
You know how much dirtiness is on the ground?
Dirtiness. I bet there's a lot of dirtiness.
That's a dirtiness.
All right, that's it for today. We'll stop there. I want to have that half angle. I'm going to hand you back some papers. If you turn in some late work, that's great.
I do have one question. Mr. Ward,
What's your question?
why do you drink Dr. Topper instead of Dr. Pepper?
I'm trying to find the cheapest alternative that still tastes good.
Why?
Because it's funny.
Oh, top.
And it saves me a ton of money. Like Dr. Pepper costs $5 a case, that costs me $2.50 a case.
That's a
Is
ton of
it
money.
just as good?
Ton of
No.
Mr. Ward,
Yeah,
you know it would save even more money.
I know,